All right. Stream should be up and running. Everything should be good. Right. So, Advent of Code. We're now up to day number 6. And we are slowly moving into the forest. I wonder if these parts, the ones with so this is all sort of grayed out, but we still have kind of fog of war. I wonder if we ever will get to see what's in there. It doesn't really look like it. It looks like it just goes the one way this year, but maybe. Right, I have set up here. I haven't looked at it. I've been told that this one is fairly easy, but I haven't looked at it. I'm also going to try and keep an eye on my chat this time, because I saw when I was done streaming yesterday that some people had left messages in the chat, which I did not read. So one of them was about GPT-3 for AoC, which is an interesting question that we might get to at the end of this. But yeah, day 6. And again, I haven't changed to contact, so I have to live with the annoying reflections. Day 6, tuning trouble. The preparations are finally complete. Ooh. You and the elves leave camp on foot and begin to make your way toward the starfruit grove. Aha. As you move through the dense undergrowth, one of the elves gives you a handheld device. It says that it has many fancy features, but the most important one to set up right now is the communication system. Sounds like a good idea. Communication is important. However, because it's heard you have significant experience dealing with signal-based systems, I'm guessing these are, yeah. You can see, maybe you can see in the bottom left corner if you have high enough resolution that these point to older AoC solutions. He convinced the other elves that it would be okay to give you their one malfunctioning device. Surely you'll have no problem fixing it. Right, so we've got the busted one. That's nice of them. As if inspired by comedic timing, the device emits a few colorful sparks. Well, that's not great. To be able to communicate with the elves, the device needs to lock on to their signal. The signal is a series of seemingly random characters that the device receives one at a time. To fix the communication system, you need to add a subroutine to the device that detects a start of packet marker in the data stream. In the protocol being used by the elves, the start of a packet is indicated by a sequence of 4 characters that are all different. That's a surprisingly, or it's a weird thing to choose as your start of packet marker. The device will send your subroutine a data stream buffer, which is our puzzle input, and your subroutine needs to identify the first position where the 4 most recently received characters were all different. Specifically, it needs to report the number of characters from the beginning of the buffer to the end of the first such 4-character marker. Oh, to the end of the first one. Okay. For example, suppose you receive the following data stream buffer. So here we have an M, a J, a Q, and then another J. So that is not correct. That is not a 4 different one. That's not 4 different. But there we have 4 different ones. So as the first 3 characters have been reached, there haven't been enough characters received yet to find the marker. The first time a marker could occur is after the 4th character is received, making the most recent 4 characters M, J, Q, and J. because J is repeated, this isn't a marker. The first time a marker appears is after the 7th character. So yeah, 4, 5, 6, 7. So after the 7th character. Once it does, the last 4 characters received are JPQM, which are all different. In this case, your subroutine should report the value 7, because the first start of packet marker is complete after 7 characters have been processed. Here are a few more examples. How many characters need to be processed before the first start of packet marker is detected? Here is our puzzle input. Oh, it's a pretty long one. That shouldn't really be a problem. We could probably code this in about the most inefficient way, and would still be happy with it. Right. So is the input just a single line? I wonder. Yes, it's all one big long line. So let us just say that the input is supposed to be a read file input.txt, but let's do what we've done earlier and done like a test input. So we'll do this like so. And now we need to go over these and find a buffer, or find a window. Like we slide a window across and we find the window where we have 4 unique characters. So what would be the best way of doing that? I wonder. We did do the string to set thing. So of course a set of 4 unique characters would have cardinality of 4 or a size of 4. So we could slide along and grab sort of 4 and 4 slices as we go. If you look in the setutils package, I believe it was, there is a toSet of an iterator. So we can give it any iterator, and it will give us a set. Oh, an iterable, not an iterator. So anything that's iterable. So for example, in this case, hello world. All of a sudden my mouse stopped clicking. Okay, that's weird. Slightly disconcerting. Oh, only in Firefox. I swear, this is the second time on stream that Firefox has died on me. And it usually never dies on me. I wonder if it's like Restream that does it. Let's see. Okay, so Firefox is apparently still running, even though I told it to quit. There we go. Firefox won't start a new copy if you already have a copy running. I'm gonna move both of those, so I put the one that I intend to have here. Oh well, the other one was empty. Let me just quickly double check that the stream is still up. Yep, stream looks fine. So, sorry about that. Someone commented, Firefox has been doing that for you too. Only while streaming or in general? because I only have the problem while I'm streaming. Like, I use Firefox all day. Right. I use it all day at work, and it's the browser I use. And it crashes from time to time, but nothing like this. Right, this here it passes a range. Here we have an iterator. We have a toOpen array. So what we could do is just grab a normal slice. But there have been talk lately about sort of the thing with strings. Like if I just said, if we in our code said for I in 0.input.high, for example, which would loop over all the indexes in this. Of course, we could say minus 4 or something. Well, yeah, let's actually do that. Minus 4. And then we echo out something like input from I to I plus 4. Let's do that. So this should output sort of all our for length sort of substrings. So you can see it, the characters sort of slide along. And that looks to work just fine. GSML should be the last. GSML needed. We can go all the way to 4, of course, because we're only adding 3. We have SMLB. So that's all our four letter slices. So we could do that. What we also could do is do a toOpen array with a start and an end, plus 3. Of course, in this case, it won't matter because echo, right, okay, it actually created arrays of them. But this, as the documentation here sort of hints at, but doesn't really explicitly say anywhere, these are slices. So these are sort of passed, they're not passed by, like, when we're doing the slicing, we are creating this substring. We are creating all of these substrings, which are passed through the memory allocator and then deallocated afterwards. But in this case, we're sort of creating a sort of pseudo object. It doesn't really exist. It's a pointer to this original string with an offset, stuff like that. So it's sort of not actually a type, but kind of. Of course, in this case, it then turns it into a string because we're doing echo. So it doesn't really matter in this case. But of course, we want to turn this into a set. And for that, we need set utils. So if we have a look at this, now we have sets. And of course, for our first ones, M, J, Q, J. So J appears twice. So that is only sort of created, that only exists in the set once. But from here on out, they're all nice and unique. So what we can do here, we can then check our cardinality, which should be the size of them. So you can see 3, 3, 3, 4, 4, 4, 4, 4, which is what we expected. And then we can check if this cardinality is equal to 4, echo out I, but I believe it should be I plus 4, because we are looping sort of, we're looping from 0, adding on something extra, and we want this to return 7, which is what we get. And of course, this is our start of packet, so we just want to break if we find one which is 4. Now, the benefit of doing this to open array thing is that now we're not creating an actual string out of our objects. We're not creating all those tiny strings. We're directly converting them to sets, because this iterates over the pointer with the offsets and all of that. So we're directly creating our character set. So this should be faster than doing the slicing. Of course, for inputs of this size, shouldn't really matter. But there we have our answer. Now I'm actually curious. What is the speed difference? Oops. I know time is not the best thing to measure speed. Right. I'm not sure this would even be... I'm not sure we would even be able to tell the difference. So, let's see. Nope. Exactly the same output. So, for this size of program, no discernible difference. Right, that's the right answer. You're 1 gold star closer. So let's just change that back, because we still want to show off sort of the nicer solution. Or the more interesting, at least. Part 2. Your device's communication system is correctly detecting packets, but still isn't working. It looks like it also needs to look for messages. A start of message marker is just like a start of packet marker, except it consists of 14 distinct characters rather than 4. Here are the first positions of start of message characters for all of the above examples. First marker after character 19. Oh. Is that it? Well, that's not very interesting. I mean, that is like by far one of the easiest ones so far. So open up day 2. Now we just make this 13 and that 13 and that 14 and this 14. We can test that on our test input, and that should give us our answer. So 19, yeah, 19 for this thing. Of course, we could split this into a like a window size parameter. Minus window size. Let's just do this. That makes it 1 smaller. So instead of subtracting 14, it now kind of subtracts 13. Plus window size minus 1 is equal to window size and plus window size. Still 19. If we go to window size 4, now we have 7. So that seems to work. Try it on our full input. Takes most of the time spent compiling. That should be our answer. And that's the right answer. You're 1 gold star closer to collecting enough star fruit. You completed day 6. Oh, apparently Restream bot left my chat, which I guess might mean that the stream is down, which isn't great. I don't know. YouTube stream seems to still be up. About the Twitch stream. Yep, not as pop. Anyways, that was day 6. Nice and simple. Ooh, it seems like this might be a river, and not. I was imagining this was some sort of like lagoon, and we were going off on foot. But it seems like, well, I guess we are going off on foot. But there seems to be like a river going in here. That's nice. I like these maps sort of slowly revealing themselves. It's a nice little thing. But yeah, that was pretty much it for day 6. I don't really have much to add. Kind of disappointed by how easy this was. I think this is our shortest solution thus far. 9 lines for part 2 and 7 for line 1. Of course, this is also actually 7 lines. I just introduced the constant. Yeah, that's pretty much it for day 2 or day 6. So yeah, hope you still enjoy Advent of Code, and hope to see you next